Good morning, my dear students. As there is no power today, so we will today take our class on the board. Okay, fine. I would like to tell you about sum, add and subtract blocks, then product and divide blocks. Okay. You can access these blocks from the math function sub-library in the Simulink library browser window. Now, the sum, add and subtract blocks, they are essentially the same. By changing the list of signs, we can force this sum block to either add or subtract the inputs. So, in the list of signs field box which is present in the sum block parameters dialog window, we can insert list of positive and negative signs. By default, in the list of signs parameters, you will see a vertical bar, then plus plus. This bar is used to denote the space. It is used for spacing. Plus plus, there are two plus, it denotes number of inputs. So there will be two input ports on the sum block, and this sum block will add these two inputs, apply it at the okay, sorry for the interruption. So the two inputs which are applied at the sum block gets added. Now, when you enter in the list of signs, when we enter like this, plus plus vertical bar, the block appears to be like this. Plus is added on the top, then this next input is added here, and then space. Now, if you enter a list of signs like this, vertical bar, plus, minus, space, then plus, then minus, the input which is applied at this port will get subtracted from the input which is applied at this port. Now this is circular shape, round shape. We can change the shape also to rectangular by selecting the shape from the icon shape menu in the block parameters dialog box. Whenever you see a downward black arrow in the block parameters dialog box, a downward filled black arrow, this is a downward arrow. Whenever you see it in the block parameter dialog box, it indicates that you have to click on this in order to access the drop down menu. Okay. Now, product and divide blocks, they are also interchangeable. In the product block parameter dialog window, you can insert a list of asterisks and forward slashes to define number of inputs and their distribution. How you will multiply, whether you want to multiply or whether that input needs to be divided, so distribution of inputs. So if I enter in this field box number of inputs, this is the field box. Now forward slash asterisk, forward slash asterisk, asterisk. So there will be 5 inputs, 5 input ports, 1, 2, 3, 4, 5. First division, second multiplication, third division, fourth multiplication, fifth multiplication. The input applied here will be divided, the input applied here will be multiplied. Okay, now the task which you need to perform to evaluate a polynomial This is a polynomial and x is equal to 3 raised to the power 0.7. So we will use a polynomial block for this. Polynomial block evaluates a polynomial for the input u, and we need to enter the coefficients. These are the 1, minus 3, 5, minus 4, 3, 2. These are the coefficients of the polynomial. These are entered as a vector in the decreasing powers of input variable, which may be u, which may be x. So you will enter them and then you can evaluate. So this is task for you. Now second task, you have to plot a function y x is equal to x minus 1 into x minus 3 square into x minus 9 square. I would like to tell you this asterisk sign denotes the multiplication in MATLAB or Simulink. This sign denotes the exponentiation. Okay, so you have to evaluate it. How to define this x? To define x, you can use a ramp block. Ramp block generates a continuously increasing or decreasing wave which is started at a specified time, and the value also changes at a specified rate. For example, the output of a ramp block, fine, you can access it from the sources library, is given by the expression out t is equal to initial output plus slope into t. You will get a slope field box in the ramp parameter dialog box. If you, by default it is 1, okay, then initial output parameter by default it is 0. You can set whatever you want. Suppose if you keep the default settings, then initial output is 0, at t is equal to 0, ramp is generating 0 value. Slope is 1, by default it is 1 and into t. So what will be the output of a ramp at t is equal to 1? 0 plus 1 into t. So it will be equal to t is 1, 1. At t is equal to 2, it will be output at t is equal to 1, which is 1 plus, sorry, initial output is 0 always. So at t is equal to 2, initial output is 0 plus slope is 1 and t is 2. So at t is equal to 2, you will get 2. At t is equal to 3, 3. So it depends upon slope how the value changes and the value of the initial output. So you can use ramp here to define x. Rest you can use math blocks from the math function sublibrary, and you will do it and show it to me tomorrow. Thank you so much. Okay, because the power has come, so I am showing you the live demo. Now we have to evaluate the polynomial px is equal to x raised to the power 6 minus 3x raised to the power 5 plus 5x raised to the power 3 minus 4x square plus 3x plus 2. So access this polynomial block. Double click on it. Now we have to enter the coefficients as a vector. In MATLAB, we will use the same MATLAB index. We will enter the coefficients in square bracket. So first of all, type square bracket. Now enter the coefficients in the decreasing powers of x. So the coefficient of x raised to the power 6 is 1. Type 1. Then give space. Then type coefficient of x raised to the power 5 is minus 3, type minus 3. Then give space. Then the coefficient of x raised to the power 4 is 0. So type 0. Then coefficient of x raised to the power 3 is 5. Give space and type 5. Coefficient of x raised to the power 2 is minus 4. Give space and type minus 4. Coefficient of x raised to the power 1 is 3. Give space and then 3. Then coefficient of x raised to the power 0 is 2. So give type 2 after giving space. So you must remember to enter the coefficient of x raised to the power 4, which is not present here, and you will enter it as 0. 6543210. So for x raised to the power 4, the coefficient would be entered as 0. Click apply and then OK. I have already entered them, so click OK. Now this is constant. So suppose if you write 1, then apply, OK, then run button. So you can say the value comes out to be 4, as we have to evaluate it at 3 minus 3.7. Fine, click apply, OK, rerun the simulation. The display block is displaying 4329. So I can show you the result. Okay, so this is all for today's class. Thank you very much.